Determine the moment of the force F about the x and y and the z-axis. Use scalar analysis, so they don't want us to do the cross product. So let's first break down this force into its components. So here you have the force here, 500, goes into the Fxy component there and the Fz component. So the Fxy is the 400, so that's 500, so 345, so that's 400. 400. And the Fz then is equal to the 300. Now the xy force can also be broken into a 3, 4, 5 triangle. So the x component here is going to be 3/5 of 400, and the Fy will be 4/5 of 400, and that equals 240 and 320. Now the x component is negative, so we could call that the negative direction, but I think the direction is clear in the picture. So now to do the moment in the x direction, let's look at what of these three components will cause rotation or moment about the x. I guess not actual rotation, but could. So we have a z component. If the z is going up, it will cause rotation about the x. Also, the y component will cause rotation about the x. So let's say negative Fy times the z component will cause rotation. Fy will cause rotation this direction, which if you do the right hand rule would be negative. So negative Fy times z plus Fz times y. And so the force up times the y direction will cause rotation this way, making it positive. So we have negative 320 times 3 plus 300 times 2, and that equals negative 360 Newton meters. My, rotation about the y-axis, will be negative Fx times z plus Fz times x. So the force in the x direction times the z height, so that's negative 240 times 3, and the force in the z direction times the x distance, the distance from the y-axis. So that's 300 times 2, and that equals negative 120 Newton meters. And moment about the z-axis is Fx times y minus Fy times x. So Fx is the force in the x direction, again times the Fx, rotation about the z, so Fx times the y distance, and then Fy times the x distance. So that's 240 times 2 minus 320 times 2, and that equals negative 160 Newton meters.